FindRoot. In this video, we will learn how to use the FindRoot command, which searches for a numeric root starting from a given point. To understand what this means, let's look at these two examples. First, find the first two positive solutions to the equation tangent of x equals x. Before we use the FindRoot command, let's plot on the same graph both the equation y equals tangent of x and y equals x. We will plot from 0 to 15. What we see in this graph is that the equation tangent of x equals x has infinitely many solutions. There's one solution here at x equals 0, and then we have infinitely many solutions continuing on. When Mathematica is going to solve this equation, it does not know which one of these solutions it wants. So we have to tell Mathematica which solution by picking a value close to the solution that we want. The first positive solution is right here, so I will pick a starting point of 4. To run this command, we type in FindRoot, capitalizing both the F and the R. We type in our equation, tangent of x equals x. We use a double equal sign to indicate that this is an equation and that we're not setting a variable, comma, curly brace, x, which is the variable we're solving for, and our starting point 4. End bracket. Shift enter, and we see Mathematica's found the solution to 5 digits, 4.49341. If we want more digits, we can type comma, working precision, arrow 20. This finds the solution to 20 digits. There are two ways in which the FindRoot command works. One is you type in an equation, the variable, and your starting point. You can also type an expression which Mathematica will automatically set to 0. Let's see what I mean by that. We type in FindRoot and tangent of x minus x. What I've done is moved the x to the other side of the equation, and Mathematica is going to assume that we're solving the equation tangent of x minus x equals 0. And I'll use the starting point 8 since that is close to this solution. So x comma 8 and brace. Oh, and it looks like Mathematica found this solution here, 10.9041. 8 went over to here. So I'll type in a different number. This can happen. 7 as our starting point. And Mathematica goes to this solution. FindRoot uses Newton's method, which you will maybe learn in your Math 151 course. Let's look at this example. Solve the equation x cubed minus 2x plus 2 equals 0. There are some limitations to the FindRoot command, which we will see in this example. First, let's plot this polynomial to understand where its solutions are. Plot x cubed minus 2x plus 2. And we'll graph it from -3 to 3, -5 to 5. I'll also pick a range of -10 to 10. Here we see a graph of our polynomial. There is only one real solution to this polynomial. Let's find this one right here. And I'll pick as my starting point -2. So find root x cubed minus 2x plus 2. X, -2, curly brace, bracket. It should find this solution, which it does, -1.76. Now, something happens. There are limitations with FindRoot. If we type this again, but we enter 2, +2, as our starting point, something unusual happens. Mathematica outputs a solution that is not correct, 0.816. Clearly from the graph, there is no solution at 0.816. This polynomial only has one real root. Mathematica gives us an error and says that it, in short, has trouble understanding this. It's looking for a solution here in this region, but is unable to find one, and it kind of just gives up and gives us its best guess. This error indicates that Mathematica is unable to find a solution here, and you need to pick a different starting point.